There's quite a bit of confusion around how Logic running on an M1 Mac handles plugins. When running Logic in native mode, can you run Intel plugins or Rosetta plugins? Does loading an Intel plugin cause all plugins, even M1 native plugins, to run under Rosetta? And how much faster, if at all, are M1 plugins? I didn't know the answers to these questions myself, and so I put together a little non-scientific experiment where I'll load several plugins and just see how Logic reacts and how much CPU usage we're seeing, and see where that goes. I've created several projects. Some of them load all M1 plugins, some of them load all Rosetta or Intel plugins, and one project loads both types of plugins. And the things I'm looking for are how fast does the project load, what does the CPU load look like under Intel and Rosetta, and just really what the developer experience is like, or what the engineer experience is like for working on Logic projects under an M1 Mac. I should say that I'm running the first M1 Mac Mini, so I have technically the slowest M1 Mac Mini, if that helps you out. So anything that presumably runs well on this machine would run well on future M1, or the M1 Max, the M1 Pro, or Ultra, whatever they're calling it. So open Logic. If you're using Rosetta, it'll say using Rosetta or something here. I'm just going to create an empty project, and I'll have audio. I'm going to slide this over so we can kind of have the other half of the screen here available to us. Okay, I have my process monitor open, and I have it sort of searching for the things that Logic or the sort of applications or processes that Logic uses to host plugins. So for now, let me drag in this little guitar riff that I created. Should be able to hear it. It's just a dry DI signal of a little guitar riff, and you can see right now there's no plugins going. Also, let's just open this up for good measure, so we can see what kind of CPU usage we have. The first thing I want to do is just open up a native plugin, and I know FabFilter has updated their plugins for native M1. So, and I know a lot of people use ProQ3, so I'm just going to do that. I'm going to create a mono plugin, ProQ3. And if you look here, you have this AU hosting service for Logic Pro pop up, and it's Apple, so it's native. And this is where it gets a little confusing. So now I'm going to open up a NeuralDSP plugin. Open up Archetype Patrici here. And you'll see we have another process that popped open here. And this is the AU hosting compatibility service, which is basically the Intel version of the current AU hosting service. So to kind of put a bow on this is that you can run Logic in native mode, and it will run both native and Intel plugins. It uses two different services to host those. So if you only open native plugins, you'll only be running this AU hosting service. But if you only run Intel plugins, you'll be running this AU hosting compatibility service. And right now, the processing is basically nothing. So I think next what I want to see is I just want to open up a project with a bunch of Intel plugins and a project with a bunch of native plugins, and kind of compare their CPU usage and just how quickly they open and how they respond. Okay, I went and created a few projects. Some have all native plugins, some have all Intel plugins, and one project has a mix of both. A few of them are processing just audio, and one of them is processing Kontak, which is processing some MIDI. I thought it might be interesting to look at these to see how they compare, how quickly they open, what kind of CPU usage they have, and just kind of get an idea. Again, this is non-scientific, but it's generally kind of like how I work. So you can see here, my computer is mostly idle. And the first thing I want to do is open up the native, and it's audio processing, the FAB filter, which is like a bunch of Pro Q plugins. So we'll open it up. We can see, have a look at the CPU, what it does here. And it opened almost instantly, like really quick. And then if we scoot this over and maybe open up the CPU, performance, and I'll close this. Right now, this AU hosting service is the plugin hosting service that runs from within Logic, that runs plugins like Pro Q3 and stuff. It runs native plugins. As you can see, it's Apple architecture. And if you look at the project real quick, what I have here are just 16 bars of audio. It's like a little guitar DI riff. And then I have a Pro Q3 instance on each one of these tracks. My thinking here was just like it would load different plugins as it goes along. So instead of throwing a bunch of plugins on one single track, like this is more sort of real world where I have different tracks and different plugins running on different tracks. So what I'm going to do here is I'm just going to go back and I'm going to play it, and I want to keep an eye on the threads and the CPU usage of the hosting service. I mean, it's almost doing nothing. Wow. So yeah, it barely budged the CPU at all. But maybe let's like open a couple of these and so we can actually see some of the processing happening, just to make sure that it is happening, and replay it again. Move this over a little bit. Yeah, it's obviously higher now because it's running the plugin itself. All right, yeah, so that moved the CPU up a little bit when you open the plugins and you watch them do their thing. They're doing this live visualization as expected, but still barely touching 25% or so if you think about it. Yeah, I mean that seems pretty great to me, especially with the instant open and everything. This native plugins are fast. And it looks like it may be only using one thread. All right, so let's close this and let's take a look at the non-native one. Let's take a look at the NeuralDSP Intel plugin to see. And again, we want to see how quickly this opens. So I don't want to save that. Go back to my Finder. So yeah. This is the same thing, except it's using NeuralDSP plugins, and it's Intel. So all of NeuralDSP plugins are Intel. And we'll open it up and see how quickly it opens. Again, I'm about at 90%, 91% CPU, idle CPU. Yeah, it's obviously taking quite a bit longer to load. We'll see how quickly it loads up. and see the hosting compatibility service is like really spiked the CPU. And there we go. It loaded. That took quite a bit longer than just the FabFilter plugins. All right. The good thing is the CPU usage went back down. And for this one, as I said, I have some Archetype plugins. They're all on basic clean factory setting. Same thing. 16 bars of audio. And let's play and see where we get. It didn't play at first. Let's go. You can see it. I'm going to let it play through here, and then we'll talk about what's happening. All right, you can see that the CPU shot way up, close to 100% or over, and you also heard the audio cutting out. Like it seems like the plugins are still trying to load and process the audio at the same time. It definitely was not how it was supposed to sound, but maybe after they've done like an official load and they're sort of cached in the system, now maybe let's see if it plays the audio a little bit better and maybe doesn't use as much CPU. That's kind of my expectation, but we'll see what happens. Okay, well, one expectation was the audio would play. So the plugins, it was obviously a lot smoother that time, but still the CPU usage was around 90 to 100%. So it's quite a bit slower than at least the native FabFilter plugins. Now, you could say some of that you could chalk up to maybe the differences between the FabFilter processing and the neural processing. But I don't think you can attribute everything to that. So, yeah, I would say that as it currently stands, the Intel plugins seem to be quite a bit slower and more CPU heavy than the native plugins. So maybe the FabFilter, like maybe an EQ just doesn't do as much processing as a guitar emulator or modeler. So I tried to think of a plugin that I know that really sort of mangles audio, and one of them was the RC-20 plugin from XLN Audio. Kind of creates like a tape effect and or like adds noise and all kinds of stuff. But these plugins are all native. So again, we want to see how fast it loads and then what it sounds like when it plays. So opening this up, again, we're at same amount of CPU, idle CPU usage. Boom, almost instant again. Maybe it took a little bit longer than the FabFilter, but not by much. The CPU is up a little bit. As we've opened this up, I'm guessing it's like loading the plugins, but still a respectable amount relative to the non-native, relative to the Intel plugins. Yeah, so this is RC-20. It's kind of the retro plugin. So let's play this and see what we get. it used definitely more processing power, more CPU than the FabFilter plugins. I'm kind of curious why. Like, so we started at like 40% CPU before we played this. I wonder if that's the RC-20 plugins operating on the audio. I'm not really sure because it's still at 45%. I'm curious if it's going to release this CPU. Let's see what we got going on here, which I kind of failed to open earlier. It's still holding on to that CPU. Yeah, that's interesting. So again, to kind of put a bow on this one, it opened it way faster, and it played about half the CPU usage as the NeuralDSP plugins. Not quite as good as the FabFilter, but not near as bad as the Intel plugins, especially when you factor in how quick it was to open this project, which is kind of a big thing for me. Is like when you open the project, like you're ready to dive in and work, and you don't want to wait this really long time for all these plugins to load. Let's move on. So this project is a mix of native and Intel plugins. There's some Neural plugins, and there's the XLN Audio RC-20. And let's open it up and see how quick it opens, and we'll run through the same process again. So it's opening. Now you see we have two of these here. So we have the AU hosting service, which runs the native plugins because it's Apple. And then we have the AU hosting compatibility service, which is the Intel. And if I open up the mixer here, the RC-20s are at the front and the archetypes are at the rear. Let's just see what it sounds like. So when it was running the RC-20 plugins, it was obviously using more CPU, and then it bumped into the NeuralDSP plugins, and the compatibility host rose to the top. The compatibility service used a bit more, but you can tell that the RC-20 is doing some processing as well. Maybe let's let this play through a few times and just kind of see how it acts and what we get. All right, my read on that was the Intel plugins are using almost double the CPU and more of the native plugins. And of course it fluctuates as this is going along, but it definitely seemed like the native plugins were faster or used less CPU than the Intel plugins. You could also see that it used 4 threads. I guess each one of these represents 1 thread, maybe, and it sort of split them evenly across threads. All right, so let's close this. And there's one more, just for good measure. Like, let's process some MIDI with native Kontak, which, as we know, Kontak tends to be sort of what I would consider like a heavy plugin. Sometimes it takes a while to load, and its UI looks like it was made in the early 90s. All right, opening up here. It opened again almost instantly. You'll see that it shot the CPU up quite a bit, but it released it here. So we're back down to almost 0 CPU usage. This is kind of the same thing. I have a chord on. I have 16 bars. There's some MIDI on each bar, and there's all these Kontak grand piano instances. And let's play it first. All right, I'm at practically no CPU usage, around 7 or 8%, and it opened really quickly. So the Kontak instrument seems really performant under native, and yeah, that's awesome. So these short tests were pretty convincing to me. Like, M1 plugins are much faster, load much faster than Intel plugins, and they use way less CPU. Again, that fluctuates a little bit, but I don't think it fluctuates enough where you could say that you would want to run Intel plugins if you had an M1 plugin available, if you had a native plugin available. I think this also shows that you can run Intel plugins in Logic running in native mode. So if you have some plugins that are compatible under Rosetta, they're perfectly happy running in Logic as it's running in native mode. Yeah, so there you have it. Hopefully this answers some questions that you might have had about Logic plugins and how they're handled. I know it solved a lot of my problems or a lot of the questions that I had, and I'm just ready to get back to making music.